Welcome everyone. Thanks you for joining. My name is Mike Vermeer. I'm a business manager for our broadband business here at Panduit Corporation, and wanted to offer an introductory webinar on middle mile networks, which is a pretty popular topic these days. The digital divide investment in North America is a pretty popular topic, and the focus is on bridging that digital divide and bringing internet access to every household. And a lot of investment is going in. The industry overall invests $100 million a year, $100 billion a year, sorry, in broadband investment and broadband infrastructure going onto the market. And adding to that, there are federal government grants across NTIA, USDA, and many other agencies that are increasing this investment by up to 20%. Over $100 billion are being committed over the next decade to bridge this digital divide. A lot of the talk and communication around this investment is on the last mile, the connection to the home. But there's more and more focus and realization that there's a gap in the middle mile and the connection that service providers have to the internet, and this is resulting in conversations. For example, the Fiber Broadband Association has opened up a middle mile working group that focuses on the challenges and needs and importance of the middle mile. And the purpose of this roundtable is just to discuss the middle mile as it affects the quality of the connection to the home, and wanted to bring on a panel of experts here, panel of speakers, that just discusses that topic. So before we go through speaker introductions, I just wanted to ask, as you have any questions for the panelists or for the companies, feel free to enter in these questions and we'll get to them at the end or after the webinar. So with that, again, I'm Mike Vermeer. I'm broadband manager at Panduit Corporation, focused on helping especially the tier 3 service providers with middle mile, central office, and outside plant deployment. And with me is a panel of experts: Jose Castro, Craig Sword, and John Anians. And I want to just ask them to give themselves a brief introduction. So Jose, can you start?
Sure, Mike. My name is Jose Castro. I am the fiber research manager at Panduit. So I lead a team of optical engineers, electrical engineers that focus in communication from different levels, from data centers, from broadband networks and larger networks that imply very high bandwidth communication. So we do research in optical fiber, different types, from the most typical fiber to the most advanced fibers. We investigate transceivers and equipment that enable the communications. Thank you, Mike, for letting me participate in this panel.
Great. Craig, how about you? Can you give yourself an introduction?
You bet. Craig Sword with Anritsu. I'm the Senior Business Development Manager, focused on optical transport and other technologies within the company. I've spent 39 years in the computer and telecommunications industries, calling on everybody from tier 1s, 2s, and 3s to web scales and data centers. Have quite a bit of experience in this area.
Great, thanks, Craig. John, how about you?
Hello, my name is John Anians. I'm an FAE with Anritsu. I support transport test equipment, and I've got experience mainly in network equipment manufacturers since the mid '80s. So I've seen a lot of changes in, you know, as the network has evolved, or the networks.
Great. So here's our panel. Let's get into some of the questions and start diving into the middle mile. Maybe as a place to start, Craig, can you give us a general overview and what different variations there we might see in the middle mile? What is the middle mile?
Sure. I think your introduction was a great introduction from the standpoint of what you've got is you've got all these rural broadband initiatives that are going out and putting either fiber or other technologies directly into the homes. to break down this digital divide of rural America not having the same broadband access that what we call the NFL cities have, the big cities. And so what you've got is all of these rural broadband providers or internet service providers, ISPs, are going to have a lot of traffic that they're going to have to backhaul back to the Internet Exchange Point, or IXP. So we're going to have to build these middle mile networks that are going to be fiber optic networks, and the technologies involved may vary depending on how much traffic and what locations and what distances you're going to around the world. But so it's going to be a high-speed fiber optic network connecting those remote locations back to the big cities.
Great. And so that connection, and John, in that definition, can you, like, how much variation is there? Is every middle mile network the same, or is there a lot of rigidity to it, or could you define almost anything as a middle mile if you work hard enough?
So my feeling is the service providers are going to design their middle mile networks based on things like, what kind of service are they providing? For example, Lifeline service, or is there a big demand to make this a low cost span out to that last mile? And how quickly do we need to deploy it? There's a lot of decisions that could be made. So I imagine there could be a lot of variance in these networks as well.
Right. And so middle mile for some is a common term. For others, there's a lot of discussion around things like lit fiber, dark fiber, a lot of dark fiber going in over the last decades. How does, for anyone on the panel, how does middle mile relate to some of these other terms like lit and dark fiber?
Yeah, the middle mile is a very general term. It involves different types of networks. So a middle mile is very common name that you hear now because of the funding that happened very recently, right? Since 2022, 2023, we're seeing that money moving to that middle mile. However, work for the middle mile have started more than 10 years ago in some states. So with that experience, you can see that the middle mile is very diverse. In many cases, it might use, it might not need installation of fiber. It might buy capacity from already service provider, and they would use a light fiber, which means basically that it's already included the transceiver, the wavelength, and the connection. So the user or the rural ISP would just need to connect to the points, interconnection points. So there is a lot of, or there were a lot of dark fiber capacity in the past. Now it's being used a lot. Mm-hmm. And that can be used to provide a whole fiber to the whole solution to enable the middle mile. Now, talking about dark and light fiber, moving to the future, installing infrastructure for the middle mile need to address that need. We will have fibers that will be light, what I mean will be used, but we need to allocate for capacity. That would be the dark fiber to enable the future bandwidth that we can talk more later. That's maybe.
No, thank you for that, Jose. So the middle mile is the application, and it can sit over a dark or a lit fiber network that's maybe leased from another provider. Excellent, thank you. So having the definition of the middle mile, like, what's the risk? What happens if the middle mile isn't adequate? What's the result of that? Craig, maybe you could take a stab at that?
Sure. Everybody's going to be cost conscious when they first go out to build these middle miles, because you're going to build a connection from point A to point B, and it's going to have to be high capacity, but cost is always going to be an issue. Your capacity, your expansion, your flexibility of the technology, you're going to need all of these capabilities, because examples I would use is in about 2011, 2012, the United States carriers started rolling out 4G LTE. If you remember, it was what they called the dot race, where everybody was advertising their maps, and the red dots would pop up and show you where all of the 4G capabilities were. I remember in those days we were taking 20 megabits per second to a tower. Well, it was only a year later that we're upping that to 40, 100 megabits. So these networks are going to have the capability to be flexible, to grow, to expand. But once again, you're going to very rural parts of America, so they've got to be cost effective up front. The other thing that happened is in 2020, when COVID hit, of course, we saw huge traffic changes in the network going away from tall, shiny buildings back to the rural areas where people are working out of their homes. They're working out of either smaller offices, branch offices, or other locations. So we've already seen 2 or 3 things happen in the last 10 years that would drive us to build a highly flexible, scalable network that could handle the capacity needs out in these environments. And I think as these people get these homes that now have high-speed internet, I know if you look at my house 5 or 6 or 7 years ago, I only had 1, 2, or 3 internet devices in the house. Nowadays, you've got thermostats, you've got appliances, you've got lights, you've got alarming systems, you've got garage door openers. All of this bandwidth is just going to drive that middle mile network to grow rapidly, in my opinion.
Great. And like if there's an issue on the middle mile network, would a user see that? How would that show up if there's a problem in the middle mile network? Say if it was built as a very light, minimalist, and it wasn't sufficient, how would that show up?
So I could take that one. I think how is that's going to show up in an inability to either get bandwidth or a limited bandwidth. If that middle mile's oversubscribed and you have a heavy usage, you're of course going to see a degradation in performance. And maybe you don't meet the service level agreement that you sold that service as, because you don't have enough bandwidth to bring it back to the larger part of the network.
No, that's great, John. Thank you. Anything to add, Jose?
No, I basically agree with what Craig and John said. So especially focusing the service agreement. If we talk about that, the bid funding have a specific numbers, what should we supply, right? So they are talking about 100 meg downloads and 20 megabits uplinks. So we need to be sure, or the installers or the companies that will manage, we need to be sure that if you add all the connections points in the middle mile, that can be many towns, and in many cases, not all of them will be rural. It's going to be a combination, because this middle mile can cover 100 to 1,000 miles of fiber. So you wouldn't expect that all of them are going to be rural. There will be some areas that will be heavy consuming. So it's very important to allocate the capacity for today and for the next 10 years at least, because this is a big investment that all of us are paying for this investment. So it's very important to allocate capacity.
And great lead in, Jose, to the next question. What does that future capacity look like? What is it today, and where's it going?
Oh, okay, yeah, very good question. Today, as Craig mentioned, during the time of COVID, we saw a huge jump in capacity, in bandwidth needs in different areas, and unfortunately, rural communities didn't have that bandwidth to access to the services, to be able to access education or to work from home, and that was a big problem. So what I would say is, today, and looking at the future, there is a huge need for accessing the network for information, for data, right? And this is even growing, because when I started working in Panduit 13 years ago, if you talk about data globally in internet, we're talking about 1 zettabyte zettabyte is billion trillions of bytes. So it's a lot. It's a lot. But next year, we're going to reach 180, 160 zettabytes. So there is a lot of information that we people in the city have access, and we can download relatively fast. But it's very important to enable the same capacity in rural areas. So what is driving, as I mentioned, is the need for information, and there is the need for entertainment too, right? Videos, gaming is going to require bandwidth, but not only bandwidth, also latency, low latency. And in the future, moving to the future, we see all the trend for virtual reality or high quality video. 4K is becoming very common, and it's going to migrate to 8K. I mean, more resolution, more bandwidth, virtual reality, and AI, of course, is in the mouth of everything, and you will see more applications of AI driving more need for bandwidth.
So, and there's a lot of conversation around the growing demand for bandwidth, and one of the things that you addressed in the white paper that you recently wrote around the middle mile is really showing how real it is. And I was wondering if you could go through that analysis in brief on how real is that demand for increased bandwidth.
Sure. So now, thank you for showing this image. Basically shows the trend of bandwidth since the 80s, right? So, and it's very interesting to see in the 80s, the first connections were less than 1 kilobits per second. So we're talking about 300 bits per second initially. And now we're talking about gigabits. If you see the order of magnitude, right? I mean, it's million times, 10 million times in a lifetime. Right? I was in the school. I didn't start university at that time, and I've been, many people like me witnessed this huge growth in bandwidth consumption. So as you can see, that trend is real, and if I could access that image, I will put dots in which when I start having access to access point, I start probably with 3 megabits per second and then 10 megabits per second in 2010, 2009. And now easily I have 300, and I see many people having 1 gigabit per second. So this is a real trend in offered bandwidth. But what we need to be understand is this is the bandwidth, the projections, and that the service providers give you, to the households, to the users. And there is a little bit difference and confusion between this bandwidth, that is the one when you test your system and you see, okay, I have 300 megabits, I have 1 gigabit, and your real consumption. The real consumption, we are not machines, right? We cannot be downloading all the time. But usually there is a period on time during the day between 7 and 10 in which many people coming home start accessing internet, video, a family start looking sometimes different TVs with high resolution. So that is where we see the need and growth for this bandwidth going to the houses. And this is today. Now imagine going to 8K resolution, imagine virtual reality with the glasses that many companies are advertising. That is significant more bandwidth, and latency is something very important that perhaps we touch base later on.
Yeah, it's really interesting. I don't have the data depth that you have, but just colloquially, I had access to only 75 megabit. Oh, it was a couple of years ago, and I thought, well, how could I ever need more than that? And now I have 300, and we're stretching. So yeah. It's I mean, even in those terms, it's real.
I could remember 56 kilobits per second being a screaming connection. So
yeah, yeah, and I mean, and the trend doesn't lie. So I don't expect to automatically go flat all of a sudden. Good. So let's go into the middle mile. So we've established it's what it is and its importance. If you're an internet service provider, like how do you plan for it? Maybe to start, who are some of the key resources, key companies, teams that should be included? How does somebody get started on this? Maybe Craig, start with you.
Sure. So first you've got the people at the edge of the network. Once again, you've got the rural broadband providers or internet service providers. Some of those have not used these technologies before. They haven't adapted to these technologies before, especially in some of the very rural areas. I attended one of the Texas BEAD program meetings about 2 months ago, and one of their biggest concerns was about training. So you've got the ISPs out at that end. I believe the IXP or Internet Exchange Point people, they understand this kind of technology. They understand this market. They've been doing peering and long haul networks and data center interconnects for years. So everybody in between, the dark fiber providers, everyone involved. The key resources you're going to need teams of network design and planning. You're going to have a fiber acquisition team because no matter where the fiber is today, you're going to have to either get dark fiber or leased circuits. Jose talked about that a minute ago about the various options. But in a lot of cases, even some of those, you're going to have to do what you call the mile connection. In other words, you've got an IXP and you've got a rural provider, but they're a mile apart where they connect. So somebody's going to have to run that dark fiber to connect the two. You're going to have outside plant people. All of these you got to do right of ways. You've got to go find manholes and conduits and things to run these through. And how do you get them into and out of the building? So there's large resources there. You've got engineering and maintenance because once they're put up and running, somebody has to continue to monitor and run it. You've got NOC people. So once again, when I went to one of the BEAD program events here in Texas, one of their biggest concerns was training. A lot of these environments are copper today with DSL and other technologies. A lot of them are moving towards fiber with these new BEAD programs and with the money that's coming out. So they're concerned about the people being trained, about the cohesion of all these teams working together in a new environment like fiber. And they're also worried about how do I interact with all these suppliers that I've never interacted with it before in the past. And so they're going to need education and support, and they're going to need new tools for all of these connections. So, things like OTDRs to shoot the fiber to make sure it is what you paid for. Then you're going to have optical spectrum analyzers to look at what channels you're running on these fibers. Then you're going to have to look at BERTs and other technologies at the high end to make sure that if you're putting in a 100 gig circuit or a 200 gig circuit, that you're actually getting that kind of performance out of the network.
So it's not a small team. It's a pretty significant undertaking. You mentioned IXP. Could you describe? They're one of the players here. Could you go a little deeper? Just maybe give a brief overview of what an IXP is.
Sure. So the IXPs are the ones that are going to have the huge pipes between data centers that are going to basically provide all of this broadband content. So no matter who you're getting your content from, whether it's one of the big 5 or 6, it's being piped through these centers, or whether you're doing it over the top, it's going to be coming through these centers. And of course, they all have peering agreements and things between them so that they can move the data around quickly and efficiently. You've also got the hyperscale companies like the Amazons, Googles, Microsofts, Meta, and Facebook. All of these people have lots of big data centers, lots of big data connections. Of course, everybody talks about the data center connections inside the data center being right now 800, 1.2 terabits, but that's getting information from machine learning to compute to memory and back and forth. Outside these data centers, if you've got primary and backup data centers, you've got to move all that data around as well. And so there's going to be huge pipes for that as well.
Cool. Yeah. So one of the things that needs to be deployed is the optical technology. Jose, what should those discussions be around say technology or bandwidth or things like that? Are there early decisions that need to be made in the planning of the middle mile?
Yes, optical technology involves many components, right? But fundamentally, I would say we need to start with the fiber capacity. And the reason is because technologies evolve at different pace. Transceiver technology is evolving very fast. So basically every 2 years or less than that, you see a new solution. And we participate in IEEE a lot. So we see right now developing of 200 gigabytes per second per wavelength, per color of laser. So imagine that you can put 40, 48 of these in a fiber. It's significant, right? And now we haven't even finished. We are planning to finish in 2026, and people is already talking about 400 gig per color per laser. So for that reason, initially we need to focus in the fiber capacity. Fiber also has been evolving, but which is very interesting is the most suitable fiber for the installations today is the fiber that was developed 20 years ago. So the old fiber, the standard fiber, is the one that enables more capacity today, especially because it can work with the coherent transceivers that make correction for dispersion. So it becomes very interesting to see fiber evolving, but basically the most cost-effective way to install a fiber is a fiber that has been used for many, many years. So talking about that, then capacity, we need to be sure that we have enough number of fibers. So the fiber is not going to be a super innovative fiber like the hollow core fiber or something like that, at least not in the beginning, but we need to be sure that we have enough strands of fiber in the cable, enough capacity in the cable. And that's very important, yeah.
So today you don't need to worry so much about what type of fiber. It's pretty much all going to be single mode, right? Not hollow core and some other exciting things that are coming down the pipeline. So mostly the same type of fiber, but the actual optic technology could be evolving for how the data is transferred over the fiber. So today you say almost everything's coherent, or over the last state of the art might still be coherent, or for the things going in today, what is typical?
I would say for this distance is moving towards coherent, right? I mean, coherent has been here for probably 14 years and becoming more relevant. I mean, evolving very fast. But you might find some connections that are not coherent today, are just standard. Well, let me define coherent. Coherent is when you modulate also the phase of the light, not only the power. Whereas the traditional transceivers or communication that we use in data centers is just power, moving the power from different level of powers. So coherent, because you modify the phase of the light, is like a Wi-Fi system, enables significantly more capacity. So yes.
In scale, how much more capacity can you get on coherent versus the traditional WDM?
Oh, that's a very good question. So right now we are in coherent for pluggable transceivers. You have 400 gigabytes per second. And I wrote the paper for 400 gigabytes per second. Right now they are moving. There are new products just released for 800 gigabytes per second. So in data centers, you also have 400 gigabytes per second. The difference is that the reach, the distance for coherent can go to 100 kilometers, 1,000 kilometers, whereas data centers is limited to 10 kilometers. So when I mention capacity, it's basically the bandwidth times distance. So it's a combination of bandwidth and distance. So coherent enables the distance. So you cannot use transceiver for data centers for the same speed, 400 gig, for more than 10 kilometers. So, yeah.
No, that's a good overview. Have changes in optical technology affected the business of designing or operating the middle mile. Craig, any insight that you can share on that?
Sure. As coherent has come out and all of these technologies have gotten extremely complicated and difficult. Once again, I go back, we were joking the other day about sonnet. You know, there were people that were cleaning sonnet fibers on their shirts or their coats or wiping them with anything. These new technologies require very disciplined installation, maintenance, turn up, test, and then as they go on, you must have a much higher maintenance level for all of your equipment. So where it's housed, where it's located, the dust of the environment, the temperature ranges of the environment, all of these things have evolved and are getting very complex with all of this equipment. So as we build these higher speed, more complex network, it's going to take better training, better test and measurement, better people, and better overall maintenance and capabilities from the company that's deploying them to keep them up and running.
And as a result, also many times the bandwidth capability, like Jose was talking about.
Absolutely.
Yep.
At one of the last conferences I went to, they were talking, there were 3 or 4 RFPs out for C+L band. So that means you've got over 200 channels at 400 gigs. So these networks are getting very large with high capacity.
Has it changed how the networks are tested? Maybe this would be for John, like the changes in technology. Sorry, John, I think you're muted. So you're talking, but.
Sorry.
No, I hear you. Great.
So yeah, as technology moves forward, everything is becoming more condensed. You have DWDM. It does change how you test things. You might incorporate a optical spectrum analyzer, for example, leveling your optical plant. These are important because you have these wavelengths traveling right next to each other. But as it comes to the actual span being tested, and it's pretty nice. The actual connection is kind of the same. So 400 gigs there, although you need your test equipment to support it, or ZR plus, the actual testing of that singular connection over one of the many wavelengths on the DWDM path is essentially the same. So you're testing segment to segment, but you are looking at things, other parameters that are specific to the technology that your transceivers support. So there might be other parameters you're interested in, like forward error correction or optical signal to noise ratio. There's a bunch of things to be concerned with beyond just bit error rate, right? You kind of want to know what your margins are. You don't want to be operating your connection at the absolute limit of forward error correction, for example, because it won't be able to absorb any impairments it might encounter in your day-to-day operation. Does that answer your question?
Yeah, and on at a really high level, it sounds like as the technology gets more complex to put more data over the fiber, there are more parameters that you're going to have to test, and your test equipment needs to get more capable. If that's a good summary.
Sure.
Mike, if I can add something to that. So yeah, I agree completely with John. The test might look very similar. I mean, we're talking bit error rate testing, signal to noise ratio. Something interesting is as you go higher speed, the transceivers need more power. So one problem that I have, and I have to thank you, John, for providing some equipment, is that I couldn't test some transceivers because each transceiver was consuming like 23 watts. So normally in data center, the power consumption for transceiver for 400 gig is 13 watts, 14 watts. So there is some changes in the equipment, although the test at high level is similar, the test equipment have to be a little bit different. And John, I don't know if you can help with that. I mean, there is some power trend to increase the power consumption for transceivers they go faster and faster.
It's certainly a concern. I've raised that need to my my people who plan our products. This is certainly a concern to end users for sure, and it's something to keep in mind. As the line rates increase, so does the power consumption, it seems. So it's a very good point, Jose.
Good. And we've been talking about testing, but one aspect of testing then is going to be ongoing operation. Now, no network anywhere is just set it and forget it and don't need to maintain it at all. How should an operator think through, once they have a middle mile in place, how do they maintain it?
So from my experience, I have seen a kind of set it and forget it mentality with some operators, and others are very diligent on the day of construction. They have records of performance, and then they have intervals at which they check the quality or the performance in maintenance windows of their spans, of their connections. So they'll have a record to compare in periods of time based on their maintenance plan. They also have day-to-day performance monitoring parameters that they can view on their network elements. So in combination with everything, I think the ones that keep records and have a maintenance plan can actually see a degradation coming. This is not going to prevent like a backhoe incident, from taking your span down or something like that. No offense to the backhoe operators, but sometimes you can't foresee a degradation or an outage because there's external actors. But as equipment ages and the world happens to them, you could definitely start to see a trend when you need to mitigate a potential outage by addressing it based on these measurements.
I don't know if you have any examples, but can you describe how the network links degrade? Like what are the things that are happening to these links that result in poor measurement? Anything you can share there?
So, and again, this is just from my experience. There may be others, but some of the things that'll, that come to my mind are, weather, wind, temperature changes. This acts on all of this equipment on the fiber and the transceivers. If they're not in, an environmental vault or something. Just dust and dirt, and then there's the addition of service. People will be in there installing new spans, for example. They may actually damage the existing spans or degrade them. Like maybe they cause a macro bend because they've added some other fibers into the middle mile going to the end users. Those are some examples.
Thank you. So this concludes the topics that we wanted to talk about. Anything else to add overall? Like what is the takeaway that service providers should have when they think about the middle mile? Where should we leave them?
So maybe I jump in. Initially, is the capacity, in my view, right? I mean, looking at the capacity, we're using public funds, so we need to be sure that we address the capacity not only today for this decade, looking at the applications that will drive the capacity. Secondly is the fiber. I mean, the capacity relate how many fibers sometimes most of the cost is not really in the fiber, and most of the cost is in the making the installing the conduit, making the trenches. So if you compare cost and then compare with equipment, sometimes it makes sense to add more capacity. Instead of putting 144 fiber, let's put 288 fiber, and you will see perhaps a very small increase in cost that you allocate for capacity that can be paid in the future, because you can probably sell that fiber capacity to other companies in the future, or allocate for a growth that is unexpected today.
Great. Any last thoughts or takeaways from you, Craig? Or John?
I was just going to say, I think what it comes down to in the end is, like a lot of these projects over the last 40 years, is it's going to be a stretch between business and technology, right? We've got to get these middle miles built. We've got deadlines to get them built by. They've got to be, quote, future-proof for the next 10 years, which there is no such thing as future-proof, as we've all seen and talked about over the last hour. With growing demands, all the new technologies that are coming out that are going to drive more bandwidth. But in the meantime, we've still got to get the job done. So we've got to analyze these business requirements, look at the technology, and then plan a network that is flexible, has capacity growth, and can handle the bandwidth demands that start coming out of these rural broadband networks.
Yeah, and really that sums up also why the middle mile is important, because it serves that last mile and the data that's being generated and used at the edge, in the homes, at the business. It all has to transport over the middle mile. So thank you all for your participation on the panel. Jose, Craig, and John, really appreciate it. Thank you for attending.